Hi everyone, and welcome to this lecture on cost surfaces using straight line distances. We previously went over how to compute cost surfaces using row and column distances. While that method was quite easy, it doesn't always capture the most efficient or quickest way to travel between two cells. Straight line distances travel directly between the centroid of the cell and the centroid of another cell. In this example, the distance travels between the source cell and the center cell through a diagonal distance. The equation for computing cost is still distance times friction, which means that we'll need to compute the distance of that leg between the source cell and the center cell. To do this, we'll rely on Pythagorean theorem, which states that the square of the hypotenuse of a right triangle is equal to the square root of the square of the two legs. In this case, the hypotenuse is the gold line between the source cell and the center cell, and the two legs are these maroon lines traveling along the row and column. If the equation for distance for the gold line is the square root of a squared plus b squared, where a squared and b squared are the two legs of the triangle, then we can compute distance using what we know about the raster resolution, whereby the two legs equal 10 meters and 10 meters respectively. Recall that the distance between the centroid of one cell and the centroid of another cell in this case is 10 meters. Therefore, the size of each leg is 10 meters. We can square those 10-meter values, which gives us distance of the hypotenuse equaling the square root of 200. The square root of 200 is equal to 14.14. So the distance of the gold hypotenuse is 14.14 meters. Now that only gets us part of the way there because that hypotenuse travels through two cells. So we need to break that full distance of 14.14 meters in half and then compute each distance in each of the cells times the friction value in each cell. So the cost is actually going to equal 7.07 times 1, because that's the friction in the first cell, plus 7.07 times 3, which is the friction value in the second cell. That means the total cost to travel from the source cell to the center cell using straight line distance is 28.28. The cost to travel from the source cell to the center cell using row column distance would be 30. Therefore, the straight line distance is slightly less than the row column distance. Let's try an example that's a little bit more difficult. In this example here, we want to travel from the source cell all the way over to the destination cell with the friction surface of 2. We're going to follow the same procedure where we need to calculate the distance of the gold line using Pythagorean theorem. But this time, the legs are of different distances. So the first leg up at the top is now 20 meters long because it travels through the full distances of two cells and each cell is 10 meters. The vertical leg is 10 meters. Therefore, the distance of the hypotenuse is going to equal the square root of 20 squared plus 10 squared. In other words, the distance is the square root of 500, which equals 22.36. Now this time, the hypotenuse, or that straight line distance, travels through 4 different cells to reach the destination. So we need to take that distance, divide it by 4, to get the distance traveled through each cell, which is 5.6. We can then use that distance and multiply it by the friction in each of the cells to compute our final straight line cost distance. That number is 39.1. So if you'll recall from the row column distance computation, the cost to travel from the source cell to this same cell using row column distance was 55, and the cost to travel using straight line distance is only 39.1. So again, the straight line distance is a good bit less than the row column distance. So that's it for computing cost surfaces using straight line distances. Again, there are some practice problems, and I encourage you to work through those to get a feel for how to compute these values. See you next time.